So welcome everyone to our webinar today. The webinar today is titled Sustainable Power Systems Designed for Remote Communities. And this webinar will be part of the CSE's Climate Action webinar series. I'll begin with introducing myself. My name is Evangeline Arithwala, and I'm the Alumni Engagement Officer with the CSE Alumni team. On behalf of the CSE team, we welcome you all for this live webinar. Today we have with us our guest, our webinar speaker, Dr. Niebert Blair. Hello, Dr. Blair. Nice of you to join us, and thank you for presenting your topic. Dr. Blair is the Capacity Building Advisor for the 11th European Development Fund Technical Assistance Program for Sustainable Energy in the Caribbean, TAPSEC. Here is where she coordinates the implementation of the program's international and regional exchange of specific solutions, focusing primarily on the application of innovative technologies, financing models, and regulatory mechanisms to renewable energy and energy efficiency sectors within the CARI Forum. Dr. Blair is a 2008 Commonwealth Shedd Scholar from Guyana. She completed her MPhil in Industrial Systems Manufacture and Management at the University of Cambridge. I will now leave the floor open to Dr. Blair to start with her presentation and give a further introduction about herself and her expertise and work. Over to you, Dr. Blair.
Okay, thank you very much, Eva, and good morning, everyone. Thank you for coming, and I hope that my presentation is understandable and you enjoy. You have questions that I can answer. Okay, so I'll continue. Generally, my presentation, I will try to give you a brief outline of my general motivation as to why I have decided to study sustainable design in remote communities and the contribution of that study in terms of the UN Development Goals. It has contributed to Goal 7 through to 13. We will look briefly at electrification in remote communities. I will share the care access resource for electricity sustainability approach methodology with you. We will look at the results of that, where we generated a sustainability balance with the community. And of course, we will look at the CARES case study, where I then implemented the method and assessed the sustainability balance in the community. So my general motivation. Next slide. So generally, I am from Guyana, female engineer, African descent, Guyanese, worked in both power systems engineering and manufacturing, both in the Caribbean and internationally in the UK and New Zealand, and in Europe, some of it for some time. Educational projects completed in Europe and New Zealand as well. Development of different cultural groups. I have a unique perspective. I do have some blind spots, and I bring to the table a new way of assessing our challenges. And of course, I add to the gender dynamics, as we want to have the balance. Being in the field I'm working in, it's mostly male, predominantly male. So I tend to have to give that view of work. So the general framework for development for a sustainable electricity system that benefits remote communities, that is what I am passionate about. And the reason being that because I worked in the utility sector doing power engineering and similarly in the manufacturing sector. And I've always asked myself, so what? And how can we involve persons in the design, especially in the power sector? And so that, stimulated me. I want to develop a framework that can allow for that to happen so that people can also have a part to play in the UN Development Goals. Yeah. Next slide. So the sustainable secure electricity for all in that, what I'm looking at is utility engineering challenges. We know we have the utility, and the utility consists of what? A grid with diesel generation. And then we have the rural or the end of the poles or beyond the poles group, right? And we also have to assess the end of the grid stability and how that is affected. Also, we have what we call hinterland technology access, maintenance, and economics. So the hinterland group are not connected to the grid or the rural areas because bringing on the rural communities would make the system unstable. And so we've classified those groups as hinterland persons, and they're generally demarcated because of their geography and proximity to the national grid. And it might be impossible or even uneconomical for them to be connected. So they have the challenge of technology, they have the challenge of access to maintenance and economics or the economic viability of having a microgrid system within these communities. So the problem is to determine how to establish a microgrid system that will actually work for such communities or in such communities or with such people in the communities for their development and support. Next slide. So in general, there are about 750 million persons still without access to electricity, and most of the persons that I'm talking about reside in Asia and Africa. The Latin America and the Caribbean, from where I'm from, we have a small percent, mainly in our interland regions and in countries such as Haiti, talking from a CARICOM and a regional perspective. Also, 25 million of these countries, despite being in Africa, would not be able to afford essential electricity services. Also, due to COVID crisis, this number will increase to an additional 660 million who will still be unelectrified come 2030. Next. So the Hinterland Electricity Project is some work that I did on a grid-like structure that we're trying to replicate in the remote regions of Guyana. And so after visiting these areas, being in the utility sector for a while, what we've realized is that we have tried to implement grid systems and the grid systems fail. But the reason is we want to know why is that. So what is the reason for the failure? And we've spoken with the Tushao of Bativa village. The Tushao is like a mayor of, is similar or synonymous to the mayor of a town or a city. And the Tushao said they came and they put the systems in, but now it's not working, end of quote. So what happens is that we might go in terms of to a development and implement a structure or a utility-like system, mainly a mini grid, and oftentimes the mini grid doesn't work. So the main question is, how can electric power utility engineering meet the needs of sustainable communities? So to further answer this question in the research, we look at what is known. We have the power engineering, we have the utility operation, which we're good at, and we have the finance and policy sectors. However, on the other hand, we have a remote community with needs, values, and activities doing what they do. And we also have to understand phenomena such as remote sustainability, resilience, traditional economics, anthropology. What are their aspirations? What do they want and goals? And to find a way of co-exploring how to come up with that answer. So this is where I was in the initial stage. And to do that, I identified the 3 areas. Participation in design, include the community. Need of remote residents, understand what they needed most, what is essential first. And then look at what is sustainable. What have they been doing? What will they will continue to do? And in so doing, support that local sustainability so that can help to maintain the system. So that's the approach behind going into the research or going into the community. Next. So we have developed, or what I have developed with the community by going into the community, is what I call CARES. CARES is the acronym for Community Assess Resource for Electricity Sustainability, which is basically a participatory design methodology, including the community. It has generally 5 steps, and we look at those steps. We look generally at confirmation and assessment of the community's needs and values together with the community members. We look together with the community at their energy supply options. What do they do currently? How are they supporting their energy needs? How are they satisfying those needs? And then we develop a game. We apply gamification. And gamification can be done in a number of ways. And for this, I would have selected a board game where we map onto that game the needs, values, and activities of the community, the essential ones, I must say, and the energy supply services that are readily available to the residents in the community. And we play that game. The game, as you will see in my research, is called Power, and it gamifies with the community what will be the implications of including different forms of energy systems in their community to match the needs that they have, and to extract from that play what will be some of the implicit, explicit, and latent needs that might exist. In so doing, following the results together, develop with the community an appropriate electricity solution. The solution, of course, will definitely allude to the technology to be implemented, the economic system to be sustained or applied, along with the cultural and social impacts that will come from it. Next slide. Good. So the community access resource model has been presented here. CARES explains what I have said just now, the 5 steps method, and where we have participation through design, and we have the different stages again. The preliminary aspect, though, as you will see at the very bottom of this process, or the very foundation of the process, has to be the cultural, land, geography, and history, understanding that aspect of how people live, how they work, how they interact, before going fully into working with the community. So understand the community, place and practice, and immerse yourself. So it has a lot to do with trying to be an anthropologist and living with the community and having a first-hand understanding also of what is happening in the community. Then followed by the steps of needs assessment, resource identification, and then mapping of needs with the results of the gamified system, and hence developing what we will term a sustainable electricity design. So this is the final approach of the method that was developed after it was hypothesized, tried. This is what it now looks like. Next. And so the game of, or play of power, includes a number of different factors. So based on those, you look at, you generally, or what was recommended, I will generally draw a map, or what I did, of the community. It's a lot of moving parts. We look at the resources, we look at the population, we look at resource available, resource consumption, power system, assets. Also, you map the assets and identify what I call shift projects, benefits. I'll go through these. As you will see in the diagram is showing the map in the middle. And with that map, there are the different colors on the polygon. And those different colors represent a range, a duration or interval from 5 years, or from 0 to 25 years. So the number of years they go out into the outer parts of the polygon. The population is mapped in that time frame. Resource consumption, along with the benefits and risks that the power system or the shift projects will bring, and I'll speak about the shift projects based on the resources available, all will be mapped for them to see and to play through. Each person, the game was actually played with 2 groups of people of approximately, or can be played with groups of people of approximately 10 persons per group, the most. Ideally, 5 would be good, so you can have more interactions with persons and you can hear them. So the shift projects, as I said, the shift projects are things that the community thinks they want to see in the next 25 years, which is the actual lifetime of the asset, which is the utility system that will be implemented. And with that system, to identify how they will actually realize the things they want to achieve. So they can identify any shift project, any project that they think is sustainable based on their current way of operating, any activity they wish to sustain, and we map that in this form of the gamification to assess what will be the results, what will be the benefits, and what will be the disadvantages. So that is what the approach is about. Next slide. So this research on the formulation side, it was done with the village in Guyana, Kabakaburi. And there was always one question, again, I said, to be answered. Why don't remote residents want to pay for electricity? And what do remote residents really want? So the electricity engineering designs results were surprising, and we had some new design ideas coming out from that. Next. What we had was what we considered a sustainability balance, right? And in the sustainability balance, we look at 9 key areas: biocapacity reserve, equity and equality, derived wealth, autonomy. These are the resource balance, things that they think they have, they own, and it's theirs. And then we looked at the consumptive ballast, the things that they want to trade these resource ballasts to acquire. We had a power utility, health, education, communication, products and services. These are things that they have identified that they want. And in so doing, we want to understand what is the relationship between the things they want and the things they have. That relationship has not been established. And so what I've tried to do is to formulate the balance based on the model. So there's a surplus and there is debt. Whatever goes into debt, which is beyond the prosperity line for the consumptive ballast, is no good to the community. Nevertheless, whatever goes into surplus beyond the prosperity line is what the community needs. Whatever comes below the line of the subsistence line puts the community in poverty, both on the consumptive end and the resource end. So the community is generally poor. So next. And so what I did, I developed a matrix to understand this aspect of it, and I call it the Sustainability Balance Index. So this is what this slide explains, what I just mentioned, the Sustainability Balance Index. Next slide. Following the Sustainability Balance Index, what we also do with the community or engage the community in is what we call a forward-thinking space, an in-time approach. An in-time approach comes from what we've been doing in terms of transition engineering. And the in-time approach is to say to the community, okay, we've already understand what you need, what you said you wanted. This is your sustainability balance. This is how you will maintain these things that you think are important to you. And so what can we do to help you with that? If you choose X, these are the scenarios. So this is where we do some of the scenario mapping as well, where we, together with the community, we try to identify what happened at X minus 100 years. And what do you want to happen at X plus 100 years? And we're now going to be looking strictly at the power system in this way. And then we're going to be incorporating with the power system the various activity needs that they have. So generally, an established energy consumption rate per activity will be provided so that the community also is aware of what they can do and what they can achieve, what they can maintain. And we will look at whatever might be a business as usual that will may lead into an overshoot if things continue to increase exponentially. Or what can happen if the systems are not maintained like we usually see. They run into disrepair and they can no longer use them and they become energy poor. And how to create together with them that sustainable electricity use, if it's electricity that they need. The model also gives itself a huge risk, because when you go into the community to understand the community, it might not be that the community really has a per se electricity need or maybe an energy need, definitely, but electricity need might be something else. So it lends itself to that kind of understanding of working with the community to help them to develop sustainably. And that's why I liked it a lot. So yeah, next slide. And what we're trying to do at the end of the day is to have a feedback loop into the socio-cultural, technical, and economic aspects of the community, to understand the resource balance, to see how to link the consumptive balance and the resource balance through electricity or energy supply services based on the activities, and to help to sustain that system so that that system can continue to work for the community, and that need that they have can be continued to be supplied and provided for. Next slide. Right. So the case study. So this case study took place in Kabakaburi, as you will see in the very yellow dot. I tried to put it thumbtack on it. That's where Kabakaburi is, beginning of the Amazonian area. And it's not as I should say, it is a bit developed in a way, if you want to put it that way. I'm trying to find a better word, but I'm not getting there. So there is education. Children go to school. There is a school. There is a clinic that provides health care. All transport is by boat because it's in the Amazonia. There are no roads. And of course, people like to be together, to cook and to entertain themselves and live and have a happy life. Everyone is more or less relatively happy and more or less, I would say, living in a really sustained manner. So what happened when we did the research? Next. So we identified with the community first the shift projects. Remember, we have to have the shift projects. We have to walk with the community through what happened before, where they want to go, and then create projects to get them there. And so we listened to them, and most persons in the community said they wanted to have, the first project was to have electricity for the school, because they found that education was important. So that is where the electricity service should actually be put to use. Another use would have been electricity in the clinic. And more or less, people will be happy just to have lighting systems in their homes. And these lighting systems that they would require should be for everyone, right? And it should be equitable for every new house owner that comes to build a house or wants to build a house. They should be afforded that opportunity to have a solar home system. Let me say that, a solar home system. Next slide. So the game was developed similarly to what I explained, and the different cards were prepared. So we had opportunity cards, dilemma cards, and the different shift projects, as you will see, are at the very bottom. And from the shift projects, we looked at the resource consumption, we looked at the population increase, and we looked at the resources reserve or the resource available and how things will go. We had a map. The map wasn't presented in the middle of this game at the time. It was drawn out of the area, and we had some shapes that represented different slots of land and what it would cost to have these shift projects implemented in terms of how the land will pay. So it was very interesting to see how the community interacted with that. So it helped to identify what were the needs, what would really happen when they have the system. Next slide. Right. So generally we find we had people felt that there were personal, we had to answer the question of personal equity. How do we get what we pay for, right? So that was one question that was coming out from the whole analysis of trying to provide a mini-grid solution. Autonomy. Everyone liked the idea of being autonomous on their own, not paying rents. So they prefer just to be living simply, and which they consider to be a sustainable way, instead of paying taxes and insurance. And the conversion of the natural capital for or liquefying the natural resources, most persons weren't willing to do that when the results of the game was played and they saw what it meant for the community. Because if they couldn't afford it by actually labor or some economic activity within the community, which was meaning that they would have been utilizing the land, they were more or less unlikely to do so. So development doesn't benefit all equally, so no one is willing to pay. So the implementation of a microgrid system that requires people to pay rents will not work. So very much the community value the freely given benefits once these benefits are equally dispersed in the community, and the purchasing of goods is more or less a personal decision that each person would make for themselves if they want anything additional to that. So more or less they have established what I would consider, and maybe look at in my further research, what is actually living with just enough to be maybe happy or sustainable. Next. So Kabakaburi sustainability ballast. One would ask, what does it look like? Look like this. Generally, the biocapacity, the derived wealth, and the autonomy and social equity are quite high. However, the consumptive ballast, as anyone might figure, is not as great. Nevertheless, health and education are very high. Meanwhile, there's not much communication access in the area, nor manufacturing or other development activities. Hence, the utility or the electricity utility that they have available is more or less a solar home system that is providing them with just enough electricity that they need to do the things that they require essential. Next. Yeah. So what we looked at, we identified both the technical policy system and architecture and the socio-economic policy system and operating outcomes. So what we've seen technically, what people generally want and can live with would be a 65-watt DC lighting system, both for every home, lighting system for the health center and the school, and of course where the health care system works based on the demand for the community. One of the most important things, however, for the health system and productive work from lighting generally, it's that students would be able to do craft and sewing, recreational gathering, and students can do homework. They also had the option whereby in terms of healthcare, most of the health support were as a result of lots of physical activity done during the day. People were more or less involved in physical activity than the average person in a city or a town. And as well, people were eating foods that they would farm, which are not as much as one would think as well. So those were some other aspects that came out as a result of understanding what the needs were that also can be further assessed and wasn't covered in this research. And of course, the application or adaptation of local medicines, which was very interesting. Next. So the social, cultural, and political changes and impacts, we looked at that as well. And there were lots of risk in that and social spin-off activities as well. the fear of persons wanting to consume more alcoholic beverages and having, less stable homes because they found that going out to work, one person going out to work, whereas the entire family working together was not something they were willing to trade. So that was interesting as well. And infrastructural policy and systems. So how do we set up a system of maintenance for what they already claim they want, which are the solar home systems? How do we help them to do the maintenance themselves? How can we help them to even create for themselves indigenous power systems, which is very interesting. And some of the time during the research was spent on trying to find ways and means of developing power systems that can be supported locally to match what the needs and activity requirements wanted. Next. Right, and so one of the models we tried to develop was, first of all, to look at a new utility system designed for these residents. They may not, it wouldn't be feasible to maybe have a mini grid or microgrid system, because that was explored on a number of different options: run of the river, small microgrid, flywheel. It might not be economical to have that system. What it seems to be more or less economical to have is to have a solar lighting system. The challenge with that is that they are not able to maintain the system, and we know that system is not being developed locally. It has to be imported. Can they provide that system for themselves? Some of them can, while others through the government will have received a solar lighting system. So they are already introduced to that thought of what is a minimum level of solar lighting system is. And so they are more of the opinion that they should all have that opportunity through the government to have a small solar lighting system or home system that they can actually access for themselves. And they, if they need to have a further system, they take it from there. So that model was to have this new utility system that will do something similar to what I explained in terms of the CARES analysis, work with the community, with their local systems, and try to help them in terms of getting the necessary parts or services or maintenance to the systems they already have, how to monitor those systems. Next. So generally what we did, or what I worked with them to find innovative ways of developing like a short-term lighting system, a mechanical lighting apparatus that maybe can work for a few things and they can actually operate and understand the systems themselves. But a lot more into that would need to be considered in the community. It was not as feasible as they would have intended it to be. But if it worked, they would have been a lot more happy having something they created for themselves and can use and can just deliver on the essential needs that they have. Next. So generally based on the research, I seem to apply the top-down approaches and using what was done so far in a bottom-up approach. And my contribution has therefore been the development of the CARES approach that bridges the top-down approach with the bottom-up approach. Next slide, final slide. So in so doing, I also looked at where I considered something called the complex cost benefit analysis in terms of reviewing what the reserve should be in terms of energy expenditure of the ballasts, the resource ballasts, and what some of the life index of assets should be in terms of the sustainability, to examine the sustainability of the resource that you're actually removing to replace with an asset, and of course the return on investment, more or less. Next. I think that's sorry. Next one. Good. So in general, I could say the solution to a sustainable electricity design will actually be a combined top-down and bottom-up approach to CARES to deliver utility system for remote residents, because of the fact that remote residents cannot fully afford the management of having a solar home system placed on each individual's home. So support in something of that nature might be a lot more lucrative. However, the economics of it will have to be further evaluated. Thank you.
Thank you, Dr. Niebert Blair, for your wonderful presentation on your work and for sharing your knowledge on the CARES approach and also the sustainable electricity model and your first-hand approach, first-hand experience of working with remote communities. That was really wonderful and really great photography, pictorial evidence that you showcased through your presentation. I will now invite attendees to ask your questions. The Q&A session is now officially open. So please do feel free to send in your questions via the chat box. Or if you are working in a similar field as Dr. Blair, please do share your views in the chat box and indicate if you'd like to unmute yourself and share your views with the wider audience and with the speaker. I do have a couple of questions that have come in from the attendees in advance to the webinar, which I would like to bring up. If you're ready, Dr. Blair?
Yeah, sure, please.
Great. So the first question is, what are your thoughts on, how are the proposed power systems sustained in remote communities?
Right. That's like, in my view, similar to what I just said. It would generally be, well, following my approach, how are they sustained? I wouldn't say whether or not they are sustained. I would say what it is that can be done to make them sustainable, because they are not, okay? When we go into communities, and I say we as power system engineers, and we're going just to create a system that we think the people need. We think people need to have electricity, and we go and we test. So this is how we work as engineers. We go, we test the resource potential in the community, and we don't ask much questions about why and what should happen. And so with that, we create something that is unsustainable. But if we utilize my approach, what I have developed there, which is a CARES approach, and to find out first from people, what is it that you wish to have, and to share with them the solution to what they say they wish to have, and to really get from them the reason why the solution might not work. We tend to want to more or less tell them it will work, but we're not more or less wanting to find out why it won't. And I think that is the different approach that was brought about through this research. So it showed that the things we are doing, which we all know already, aren't as sustainable as we profess they are. And so the community actually is what is, they are the ones who are teaching us that what we are doing is not sustainable. And that was a really different view of how to go through or go about the design. It's sadly that we cannot find a system yet to capitalize on such a task, but that was the reality of what the situation was about.
Thank you for your response, Dr. Blair. The next question is on the power system. So hoping that the power system would not increase the rate of the carbon emission based on your experience. What are your thoughts on that? What has your experience been so far?
Well, based on my experience so far, remote residents wouldn't pay for us to put in a system that they do not see fit with their community. Meanwhile, we want to have everyone electrified. So my response is, being in the area, the sector that I work in, policy and policy development, it's asking us some new questions, especially with what's going on at COP26. There's so many contradictions to what we think we know. And maybe we're not bold enough to acknowledge them, but more or less, I must say, I have to acknowledge that we as engineers in the power industry, when it comes to working towards a sustainable development goal of providing electricity services to the end of the pole person, and the solutions that we're coming up with, which we are tooting are sustainable, might not be as sustainable as we think they are. And the communities, they are showing us that, but we are not taking that message away. Instead, the message that we have been taking away, and I've been very much involved in this, is that the systems don't work. The systems don't work. And there's a reason why the systems don't work, because the systems do not fit in their sustainability atlas, if you want to call it that way, in their sustainable world, how they see the world. And we might want to think that they see the world maybe ancient or whatever we might call it. We don't want, some people might be derogatory about it, but I won't. It's really a new way of thinking. A new way of economics needs to be established. And I think a lot of that has been coming out from the discussions of the COP26, is that we say we want to get away from fossil fuels, but are we really wanting to do that? Yes, we really don't know. We're in a jam. You know, there were lots of lovely speeches, especially from the Caribbean representatives there. And so I don't know. It's really a touchy situation. And what I liked about my research is I always wanted to go the other way around. When you design power systems, you design the system so that you're pushing it onto people. But if we should look at a system whereby we're designing as a pull effect, what would that pull effect mean? And I can even add a little bit on that contextually to date. Guyana, the country where I'm from, is one of the poorest countries in South America, to be fair, right? And we have over 200 interland villages of approximately 1,000 persons per village. Okay, some are small, as the village that I visited was about 650 persons, and some are even smaller than that. I think the smallest you might find, it's around 50, and the largest you might find in those villages are somewhere, I think, in the areas of not more than maybe 5,000 persons. Okay, I might be too high on that, right? Maybe 5 if my memory serves me right. Okay, and when I said 5,000, it's because that's an area where you might have two, 3 villages that we could actually cluster to actually generate the kind of electricity we wanted to do based on the resource available. But to do that, it will be uneconomical to power that 5,000 people, despite you have the stream of villagers living there. And that on itself, or that alone has opened actually my eyes, and I'm not sure how much of the economists or fellow engineers would agree, but it has opened our eyes more or less to understand how is it that we are like weighting economics, technology, environment, and happiness. How are we weighing these different phenomena, and what is it that we're really looking after at the end of the day? Do we want to really destroy the society, or are we trying to build the community, build fellowship, build what people think values most? And if what they want value to them most will need an electricity system that provides surplus of electricity, we can give them that. But that's not what they're saying. They're saying they need a system that can allow them to have lighting services, that can allow them to have education, and that can allow them to support health. So how do we build that system? All right. And I like that. I like that very much.
Thank you for a great response to that question, Dr. Blair. And it was really good of you to, highlight the importance of representation and speeches being made at COP26. And coincidentally, today's theme of focus at COP26 is lack of female representation within climate change space and even within the delegates that are present there. You being a female engineer, an Afro-Guyanese female engineer, what has been your experiences and challenges that you have come across in your field of work?
Um, Thank you for that question. In terms of challenges in my field of work, I wouldn't say I don't have challenges, but I use those challenges basically as stepping stones to help to understand things. And I have never had any kind of social issues working in my field, despite, again, it's predominantly male. What I love about doing what I'm doing is that I like maths, I like solving problems, I like complex problems, and this is a complex problem that I'm working on. So it excites me, it gives you that kick to life, that I would say. And yes, so if they're I am very much supportive of females or gender balance, gender roles within different organizations and so on. And I think sometimes I would say I am more of say that everyone has a part to play, and it's not necessary to say, okay, we need to have more females here or more males there, or it will work. It's at the end of the day how to find a way for us all, both male and female, to sit together and try to solve a problem that we're having, to overcome the challenges that we're having. So I am more of having collaboration and sharing of expertise in the field. As long as someone is well educated and can contribute, they should be a part of the discussion. But until then, I don't know how it will go in terms of having an equal amount of women and men around, or an invasion of women to take over male roles. I'm not too much of in support of such. I am more or less in support of us working together as human beings, not even race, just working together as human beings, trying to find out what is affecting us, what is affecting our planet from a wider perspective, what is affecting our environment, from a more localized perspective, and how we can work together to shape that. That's what matters, I would say.
That's a very great point to make, Dr. Blair. We have a next question from our attendee, Velma. Velma's asking if did you assess the willingness and ability to pay for the system in the community? If yes, was it lower or higher than their current energy expenditure?
Good question, Wilma. So I can now go detail into some of that I would not have done in my research. So yes, a huge part of me was to try to understand willingness to pay, and not just willingness to pay in terms of dollar values, willingness to pay in terms of understanding of the sustainability balance that they would have spoken about. And I tried to talk about it in the presentation, but I cannot give everything there. So yes, so willingness to pay was considered in a comparative level to different things. So for instance, the school that was built in the community, it came about as a result of a combined effort of the people and the government. And so they understood what was needed to provide that. Similarly, the hospital or the health center that was built. They are very much skilled. The people in the community are very much skilled. They provide their own machinery. They might look old or old-fashioned, some people might say, old machinery. So they actually did the felling of the trees, the sawing of the wood, and the building of the structures. So they to themselves can monetize that or liquidate that as to the amount of time it took them to do so, how much area of forest they needed to fell to achieve that, because I must add that they own that land that they're living on. That land is not owned by the state. And so they have concessions over that land. And very importantly, in the Amazonia, you would know that most of those lands are where people go to mine gold. And so those communities, they have the right to give concessions for gold mining if they want, and for felling of trees if they want. So we have lots of foreign persons who would come in, and they would come to the government, and then they would go to what we call the commission that we have that looks at the forest. And then if they want to have, if the interland persons or the tushao of the head of that village wishes to involve in such trade as well, he goes to the commission and offers the land, and so they know. So they know how to organize in terms of paying themselves. So they have their own economic structure that they have. So when they were offered the power systems that they now use, which are the solar home systems, they were asked to save the money that they spent on kerosene oil for flambeau lamps. That's what we call them here, for making kerosene lamps. And it was expected that they would have saved such money. And to be honest, the value of such money, if you just for interest, is just about $5 per month. If they could have saved just $5 per month for when a battery system fails or an inverter has a problem, or they might need to change a panel that they all could contribute towards, right? They didn't do it. Such a system did not materialize, and these systems were operating for over 6 years. So willingness was looked at from a wide perspective, not just you telling me that you can afford to pay $5, which we can say they can afford to pay $5 because they're saving $5. But the willingness to give me that $5 freely because of what I have given you as the government, it wasn't there. And it's not to say that it's bad or it's good, it's that they saw an improved way, they benefited from that. And so what happens in terms of behaviors, and it's something that really interests me, is that to see how us human beings, how we respond with certain behaviors to certain phenomena. And that is profound. So if they're, whether or not we say they are willing to pay, right? The question was asked specifically, are you willing to pay for this resource? The answer was yes. Then when you played the game, and after the game was completed, and you said, okay, to have electricity in the school, if you don't wish to fell so many trees, then maybe one person might leave the home or the village and go to work in the city and can contribute by sending back, say, $5. And this goes into a safety deposit, whatever, for the maintenance of the power system at the school. They weren't willing to pay because the questions were like, okay, one house has 5 kids because the average household is about 5 to 7 persons. And the houses are very far apart. That's another challenge. So there's so many challenges, so complex. So when you ask them that question, will you actually pay us then $5 a month per child if possible, just to maintain a solar home system for the school? The answer was no. And there were reasons for that answer, because they felt that it wasn't personal equity, that point that I raised there, wasn't well established. How can you say I am getting $5 of what I pay for in the use of a computer that has to be for a school of 100 students? And then you give them different time slots to work the system. And all we need for that is a generator system to run that. And yes, of course, that is looking at fossil fuels. But removing that generator system from there, if you like the solar because it gives you light. So if we give you a solar system to power, you see the magnitude of that system. So those were the willingness to pay questions that I liked about our research. And in my view, it was no. They weren't willing to give up their autonomy, those resource balance that we spoke about. They weren't willing to give up the biocapacity reserve, because felling of more trees would prevent them from doing the things they love to do, hunting and fishing. That would be gone. No wildlife. They weren't willing to give up it based on to have what we called derived wealth. Derived wealth is generally, okay, I am free to be home and I can look after X, Y, and Z persons. I can make sure my kids are safe and healthy and happy. When I'm out, that wouldn't happen. I have to pay someone to do that. I'm not going to work to get money to pay someone to look at the kids and to pay for that. So it's a very nice question. So the answer will be, I don't think so. But I want more or less in such a study, again, should I do it, to have an anthropologist there, maybe a psychologist, to actually bring some new thought to it. And that was one of the main things that came out in my research, is that such a study must always be multidimensional, multidisciplinary.
Definitely.
Thank you for the question, Thelma. Thank you.
Definitely. Your response, it just shows your passion, and it also shows how engaged the community members were in this project. Thank you so much for your response to the question. We have final question from Moses. If I can please ask Moses to unmute and ask your question directly to the speaker.
All right. Thank you, Dr. Blair, for your presentation. I'm calling from Uganda. So I was just wondering in terms of how you approach the community. I mean, the solution came from the community, but what were the factors that influenced the approach to how to make the solution? And in that community, what has been the past experience? Have there been projects that have failed because of top down, or has the community been engaged to really find a solution, and what really influenced how they solve their problems in this sector?
Thank you very much for that question, Moses. Hi to you from Uganda. Yes, the yes is to yes. The community had already implemented solar systems for the health center in 2000, and those systems failed. And with the new upgrade technologies that came along with the battery systems, closed, more or less what we want to call closed systems were developed. And then Guyana, the government of Guyana, we had decided, okay, since we have so many forests, we will make some money on our forests. We will have this carbon credits system set up. And so we, as in the government of Guyana, penned a deal with Norway. And so Norway had to pay us for not cutting off those trees, right? And as part of that fund to not cut the trees, what happened as a result of that is that monies were then given to these communities. And as such, we wanted their development. And so we decided as a government to provide each household with a solar home system. And that solar home system, the cost is just about $250. Right, just to provide them with enough lighting to do the necessary things that they have to do when there's darkness. Okay, and so in that system that they now had, they were told to maintain that system, and the maintenance would have come from the savings that they had on the kerosene, which didn't happen. So the bias from that community, like I sense in your questions, like what would have biased the community maybe towards not wanting to pay or something, or what biased them in terms of helping to generate the sustainability ballast, or what biased them in terms of when we were working together, the decisions they made in the game. And that bias, some of it I can attribute to the technical aspects which I am involved in, given my own bias, and the fact that they possibly would have left their communities and see what happens in the towns and villages. Some of them have even been to the US, so they know what happens there. And maybe that is what biased them. Yes, the literacy level in those communities are very high. It's about 85% literacy level. So people can read, people are educated. So really and truly, the environment, the air is fresh, you have trees, you can eat. So why would one want to really sacrifice that for, buying something that's just an asset that's going to be stranded? So maybe it could have been alluded to their experience with some projects that would have happened to them from a top-down approach, because there was one similar project where an NGO went in to provide for them a small generator, 300 kilowatts generator that would just provide electricity to a group of people, and then a group of buildings that can do different activities. And then they would actually just have to buy the fuel and maintain the engines, because that's all they would have had from the NGO. So yeah, I like your question, and there is that bias, and it's human nature that's an aspect that, I'm not that versed in, but I definitely would like to have an expert work with me to assess that and to see, because yeah, if they felt it would have worked, then we would have done it, but they felt it's not sustainable. True. So yeah, Moses, I hope I answered your question. If I didn't, just let me know.
No, you did answer it. Thank you.
Thank you, Moses.
Thank you, Moses, for your question. With this, we do come to an end of our Q&A session. Thank you for sending in your questions for our speaker and making the webinar engaging. If you would like to connect with Dr. Blair, you can find her on LinkedIn with the name that's provided on the slide on your screen. Dr. Blair would be happy to connect with you if you have any further questions or would like to discuss her work in more detail. So please do connect with her on LinkedIn for further discussions on this webinar topic. Dr. Niebert, Blair, thank you so much for presenting your webinar topic with us. I'm sure the attendees found it useful in understanding the current situation in Guyana and your work related to sustainable electricity model and working with remote communities. Thank you so much for sharing the information that you did during your webinar. And thank you so much for our attendees for joining us today. As mentioned, this webinar is being recorded, so I will be sharing the webinar recording with you shortly.